this lesson is very important for the chapter. Okay, 2 lessons later on this chapter uses what we're going to do today. Okay, so it's very important that we understand today what we are doing, why we're doing it, stuff like that, okay? It is called dividing polynomials, though, which makes it seem daunting. But it's not as bad as it may be. All right. So, first slide. Okay. Now, there are 2 types of problems today. Both of them in your directions will say simplify. So it's important to understand the parts and how the parts differ from what you're going to do. Okay? So the numerator in this case is a polynomial, right? 3 terms. Technically it's a trinomial, but it could be 3 terms, 4 terms, 5 terms, hence why they give it the polynomial name. Your denominator is a monomial, right? 1 term, 3xy. Now, just like the other day, when you simplified a monomial over a monomial, you did your exponent rules. Everybody remember that? Same thing here, except this is your common denominator of 3xy. So to make this more practical as far as our work goes, you need to write that as 3 separate fractions. 6x to the 4y cubed over 3xy plus 12 x to the 3rd y squared over 3xy minus 18 x squared y over 3xy. Then you go through and simplify each one individually. So your first one, you have 6 over 3 reduces to 2. X to the 4th over x gives you x cubed. Y cubed over y gives you y squared. Then it's plus. 12 over 3 gives you 4. X cubed over x gives you x squared. Y squared over y gives you just y. Minus 18 divided by 3 gives you 6. X squared over x gives you x, and your y's cancel out. They don't have to divide evenly down here. Okay, you could have fractions end up down here. That's okay. Just make sure they're simplified fractions. Okay. Now the next couple of slides have examples of problems that kind of like is how they kind of can be presented to you. All right. It's once again, it's more important to understand your notation to it and what you're dividing by. You're doing a polynomial by a monomial. So all you have to do is take this dividing by, which is 8CDF, and slide it underneath each one. Okay, and once again, you get fractions on this one. All right, everybody can see that hopefully. And then you just go through simplify it like we used to, or like we did earlier in the chapter. So you have 28, which reduces to, well, I believe, let's see, we go into 5 halves, right? Okay, 5 over 2. Then keep that fraction going for your variables. So C cubed, D, the F's cancel, minus 8 over 16 gives you 2. I think you're left with an F, right? Plus, it ends up being 1/2 because your variables fall out on that second one. So a little funny looking. You have a bigger fraction on the first one than you do the second 2. That's okay. Just keep them individually, cancel them out where you can, and then that's about it. Okay.
Question?
What's up? Okay.
It's harder.
Everybody good? Okay, last way they can kind of be notated, and this one I want you guys to pay attention to because this one shows up in your homework tonight, is like this, okay? Where you have a -1 exponent here. Don't worry about that, okay? All that basically means is this. To make that -1 exponent, you would flip it, right?
Yeah.
and then you would just move it to the bottom anyway. Correct. So you still divide by this. Okay, same thing.
Even though it says
Yes. So because it's a -1, which means you would flip it, make it 1 over 3xy, and then you would multiply both of them by that. So it ends up that you just divide each one.
by 3xy.
Yeah, by 3xy.
We're trying to be tricky, but we smart.
That's good. So you get 6x plus 9. What, x squared y z? Is that right? Okay. Next slide. Now, what the book does and how they started out is doing this by long division. Okay. Yes, the long division where you used to make the little house, put the big number on the inside of the house, little number on the outside, go through all your steps of dividing it all out to get your answer. They would do that instead of just with two numbers, with polynomial and binomials. Okay? It is a thing. Like I said, we're not going to do it until we need to. Instead of doing all of that, there is this method that is called synthetic division. And that's what we're going to focus on. Okay, synthetic division does the exact same work as long division does, just a lot faster. Okay? It's a very specific process that you've got to go through in order to make it happen. So, first thing you do, you check for two things. Number one, you make sure all powers are present, including the constant, in your polynomial. So, whatever power you start with, we're starting this one with x cubed. From x cubed down, everything has to be there. X squared, x to the first, and x to the 0. Okay? We will get to one where they don't show up. Alright? So 3, 2, 1, none. Second thing you need to check for is a coefficient of x. The coefficient of x in your binomial is 1. That's talking about this x right here. That coefficient needs to be 1. Once again, we will get to one where it's not.
You just throw it over.
Okay. But right now, this one's ready to go. Okay? So here's what you do. You take the coefficients of your polynomial. The 2, the -13, the 26, and the -24. You write them in one line. Okay, one notebook line. Leave a space right here. Okay, like leave a notebook line space worth right here. And then draw like an equal bar all the way across. Then off to the left-hand side, about the same level as this line is fine. Make a little half box, like that kind of. Okay, and in that box is going to go this number, except the opposite. So 4. Okay, and that's a key thing to remember. Okay, if you don't switch that sign, your whole problem's shot before you even do anything. So make sure you take the opposite number of this binomial. See how I circled the minus sign too?
Yeah.
See that? That's why. Make sure that sign gets included. It's an x minus 4 there, so it becomes a positive 4 over here. That's how you set it up. Everybody clear, understand, make sense? Okay? Here's the work to it. Now, you guys are going to be like, this one's stupid, man. What are we doing? Why do we need this? I'm not going to write that. And I guarantee you, you'll mess it up. Guaranteed. I'm going to write the most important thing you can write next. Ready? An arrow. Okay? Put an arrow underneath that first number. What do you think that arrow means?
Move the 2 down.
Bring the 2 down. Okay? I see it every year. Okay? In all my years teaching. All 5 of them. someone doesn't put this arrow because they think they're a hot shot, and they mess it up. Every single year, they mess it up. Okay? Put that arrow. For two reasons. Number one, it reminds you to bring this down, and that's how you're going to start your problem. Okay? I'll tell you what number two reason is in a second. Now, to start this process, here's what you do. Once you bring a number down below this line, you're going to multiply this number with 4. So 8. Okay? 8 goes underneath the negative 13. That's the other reason why you put the arrow. That way you have a block underneath the 2, so you force yourself into moving it to 8. Okay? 2 times 4 gives you 8. Moving underneath the negative 13. Okay? Now these two,
Subtract them.
actually you add them.
Okay.
So negative 13 plus 8.
5
Negative 5.
times 4.
Then you start that process over again, like Stone's already doing. Okay? Bring a number down, multiply it with the 4. So negative 5 times 4 gives you negative 20. Now it goes there. And then you add these two. 26 plus a negative 20, 6. 6 times 4, 24. Negative 24 plus 24 gives you 0. Okay? Now, the last number, I always put a little box around it. Okay? I always put a little box around that 0, or that last number. Okay? We'll talk about what that number is in just a minute. Okay? So, here's what your last step is. You just took these coefficients and you divided them by 4 and you got these numbers. Okay? These numbers are now going to be the coefficients to your answer. Okay? Here's the key. Your answer, see how this one started with x cubed?
Yeah.
Your answer starts one lower. So x squared. So 2x squared. And you go from there. So minus 5x plus 6. And that's your final answer.
Is it not always going to cross out the 0?
Okay, so.
Do it.
Yep. What goes in your box? Negative 3. Okay. Bring an arrow underneath 1. Bring that 1 down. 1 times negative 3. Negative 3. 7 plus the negative 3. 4. Okay. You're adding, you always add these two, right? So 7 plus negative 3. Think about it that way. Okay, so 7 plus negative 3, same as 7 minus 3, so you get 4. All right? 4 times negative 3 gives you negative 12. Negative 11 plus negative 12 gives you negative 23. It'll be. Okay? And that's the last number, so I'm going to put a box around it. Okay? Now, when you go to write your answer, you're started with a squared in your top, so this is going to be your coefficient to a. So a plus 4. Now, anybody know what the word for this number is going to be?
No.
Starts with an R.
Remainder.
Your remainder. Good. Okay, now, here's two ways. Think about this. Let's do, I don't know, 12 divided by 5. 5 goes into 12 how many times? Twice. we get 10, we get 2. Now, you used to write way back in the day 2R2, right?
Right, but then we bring down a 0.
We're over that. How else can you write your remainder? Decimal, okay. Fraction. How would you write the fraction here?
2/5.
2/5, right?
Yeah.
2 and 2/5. Ew, mixed number, but still. That's what you do here. Because it's your remainder was 2 and you're dividing by 5.
So negative 23 over 3. So 23 over 3.
Negative 20 minus 23 over. What are you dividing by?
3.
Nope.
Negative 3.
Nope. Nope. What are you dividing by?
A plus 3.
A plus 3. See that? It goes back to what you're dividing by in the long term, okay? This is just shortcut work here, guys. Alright? All this stuff here is shortcut work. You're still doing a squared plus 7a minus 11 divided by a plus 3. So you're dividing by a plus 3. What goes in your box? Negative 3, good. Bring the 2. Okay, I'm telling you guys, draw that arrow. Draw that arrow, it saves you some trouble. Okay, but once you kind of get the hang of this, you kind of get a rhythm to it, you know.
Yeah.
You multiply, you add, you multiply, you add, you multiply, you add. All right, so 2 times negative 3, negative 6. 3 plus negative 6.
Negative 3.
Negative 3. Negative 3 times negative 3. Whoops. Whoa, what happened there? No idea. 9. 9 minus 4? 5. 5 times negative 3?
Negative 15.
Negative 15. You get 0, okay, which is always a good thing when your remainder shows up as 0, okay? It doesn't always have to, but when it does, it's really nice, okay? Alec.
How do people mess it up like that? Don't just bring down the first number?
People don't bring down this arrow or write this arrow. What they instantly do is 2 times negative 3, which is what you're supposed to do first, but then they put that number right here. Okay? And then they start off with negative 6 here. And so they go negative 6 times negative 3 and it's 18. Then we got 21 and then it's chaos from there. Okay? So everybody for the most part does the first multiplication right as 2 times negative 3. It's just sometimes they just do it right away, and then they put that result here, and then they start again. Okay? So they're doing it right with 2 times negative 3, but then you need to put it underneath the second number. Okay? I'm not going to take off points if you don't write the arrow and you get it right. Okay? Be a hot shot. Be my guest. Just be careful. All right? If you can be a hot shot and get it right, cool. Good for you. Draw the arrow, though. All right? Okay, so we got 2. Come on. X squared minus 3x plus 5. Okay?
Yeah.
Fantastic. Next one. Ready?
No.
Okay. Take a break.
Okay.
Okay, cool. There you go.
Wait, yeah, that's 28. Plus negative 2.
What goes in your box?
Negative 2.
Negative 2. Let's double check that. Right? Okay. What are your coefficients? One person. Galloway.
4, 2, negative 4 as well.
No.
Exactly. See?
Why
I
not?
got some wrong.
Oh.
4, negative 6, 8, negative 2.
Your coefficient line, dear.
Oh, coefficient.
These coefficients, yeah.
4, 2, negative 4.
No. Ostov.
You're talking about the under the line, right?
This right here.
Oh, so you're talking about not the numbers at the top.
Not the numbers you get, but the numbers you start with, yes.
Numbers you start with?
Yes, sir.
Well, the first one wouldn't be nothing because you have to draw an arrow.
No, I'm talking about this line right here.
So the top
The line above that line.
Yes.
Oh. Well, it's just
4. All right. We
the
can
same numbers that are in the thing.
we're rushing now. What's this exponent?
4.
What's this exponent?
2.
Oh, there's no 3.
So is it 4, 3, 2? Oh!
So, there is no exponent of x to the third.
Right, correct.
Your bullet from the earlier said we need to make sure that each exponent is accounted for. So, how can you put in an x cubed without really putting in an x cubed?
Put a 0.
A 0 x to the third.
You sneaky monkey.
Ah. 4, 0, 2, -4, and 12. Be careful with that, okay? You will be right. Once you get the hang of this, guys, here's the deal with this. Once you get the hang of this, it is simple, okay? It is fast, you fly through. Don't fully rush. Make sure you do 2 things. Number 1, set these exponents, or set these numbers up right. Make sure you get your missings. Switch this sign, okay? Now, everybody pay attention. Stop reworking it real quick. Everybody stop. If this 12 is not there, you also need to put in a 0, okay? It goes from your highest power all the way down to no powers every single time. So if there's no number here at the end, you also put a 0 in for that,
Right.
okay? So when we go, now let's bring it. So 4, get a -8, -8, 16, 18, -36, -40, 80, and 92. So now, see how, so now we're still, even though an x cubed doesn't show up here, it still shows up in your answer. Okay, that's how that works. You start with an x to the 4th, so this goes to x to the 3rd. Okay, so 4, x to the 3rd, and then you keep going down from that. Okay, so it goes from 3rd to 2nd to 1st to no power to your remainder.
Yes.
Okay, Corey?
You got it right.
You do not. No. No. Okay, Miss Harris.
Will there ever be a time where there's like not one with an exponent and not the ending number? Like you have to have 2 zeros?
Say it one more time.
Will there ever be a time where you have to have like 2 zeros?
Yes, there could
Yeah,
be.
when you draw the 12 and then.
Yeah, there could. It could. Honestly, I could go x to the 4th plus x,
And then you have to add.
and you have to add in the 3rd 0, the 2nd 0, and the constant 0. Yeah. Okay.
Wow.
So you have to
Would
pay
it be
attention.
easier for that way just to do it the first way?
Well, once you switch these to polynomials, then once you switch to dividing by a binomial, you got to do synthetic or long. Okay. We got one more time. Page. Focus. Okay. Now this one I will start you off with. All right. Now, if you look at this one, there was a second thing on that list we need to make sure we hit.
Oh, that can't have.
That has to have
X.
1.
That's equal 1.
This x has to equal 1. Or this coefficient has to equal 1. Okay? Now, the easiest way to fix that is how? Starts with a D. Divide. Divide by what? 3. Okay, now, to make this work, you got to divide this by 3, this by 3, and all of this by 3. To turn your problem into x to the 4th minus 5/3 x to the 3rd plus 1/3 x squared plus 7/3 x plus 0. Okay, let's just get it in there right now. Divided by x plus 1/3.
Oh my god.
Okay.
Why is it stressful? Yeah, like, I'm kind of stressed out.
That's good. Now, in your box, now you can go through and do your division. So we have x plus 1/3 as our binomial. So in the box is going to go what?
-1/3.
Negative 1/3. Line up your coefficients. We got 1, We got negative 5/3. We got 1/3. We got 7/3. And we got 0. Alright, 4, 3, 2, 1, done. Yep. Bring one down. What's negative 5/3 plus negative 1/3?
Negative 2.
Negative 2. Okay. Negative 2 times negative 1/3. 2/3. 2/3, right? Okay. What's 2/3 plus 1/3? 1. What's 1 times negative 1/3? Negative 1/3. That doesn't look like a 3. What's 7/3 minus 1/3? 2. It's 2 times negative 1/3. Or yeah, sorry. Whoops, too fast. Negative 2/3. Add 0. Negative 2/3 is your remainder. Okay, now be careful with the next part. Here we go. Rewrite your answer just like you think you would. So x cubed minus 2x squared plus x plus 2 minus 2/3 divided by, now make sure you divide it by what you divided this by. You divided this polynomial here by x plus 1/3. Okay? Okay? Everybody see that? Now, synthetic division, like I said, is kind of a shortcut. It's kind of a backwards thing. We started this whole problem off with dividing by 3. Okay? And when we divided by 3, we had to do the whole thing by 3. Now, to tell you, to be short about it, if you did this by long division, you would get these same numbers. So you'd get 1, negative 2, 1, and 2. So that's okay. What you would not get is this fraction as a remainder. Because think, if you did this by long division, you'd be dividing by 3x plus 1. So, we need to fix our remainder now. 2/3 over x plus 1/3. That's ugly. We need to get rid of both those fractions. When you get rid of both those fractions, you have to multiply by the same number. In this case, that number is going to be what? 3. Multiply the top fraction by 3. Multiply the bottom, which will end up being a distribute, by 3. So when you go over here for your final answer, do it in blue. X to the third minus 2x squared plus x plus 2 minus 2/3 times 3 gives you 2 divided by 3 times x gives you 3x. Whoops. Oh, come on. That's the second time now. Plus 3 times 1/3, 1.
So we're gonna end up with,
Most cases you will end up with what you started with, yes. There are some cases out there where you don't. That's okay. Alright? Any questions?
so are we only doing the synthetic division now?
Yeah, we're not doing long.
So like what we first did on the problem we're not doing?
Well, what we first did on those first 2 or 3, we'll do that, yeah. But once you start dividing by a binomial like this, then you have to do synthetic division.
So it's gonna, like, the first one's a direction to simplify, what will this say?
Simplify. Alright, your homework is page 247, 13 through 15, 20 through 27.